There are three major pathways for the synthesis of triglycerides referred to as the glycerol 3-phosphate pathway, the dihydroxyacone phosphate pathway, and the monoacylglycerol pathway. The glycerol 3-phosphate pathway of triglyceride synthesis is referred to as the Kennedy pathway after Eugene Kennedy, who first worked out the pathway of triglyceride synthesis and published his results in 1960. The glycerol 3-phosphate pathway is the major pathway utilized for triglyceride synthesis in hepatocytes. However, under conditions of insulin stimulation of the liver, glycolysis is highly active as a means to drive the excess glucose carbons into fatty acid synthesis. Under these conditions, the DHAP pathway using the DHAP derived from glycolysis is the major triglyceride synthesis pathway in the liver. Within adipocytes, which lack expression of glycerol kinase, the DHAP derived from glycolysis is absolutely required for triglyceride synthesis. Thus, the DHAP pathway is the predominant triglyceride synthesis pathway in these cells. The monoacylglycerol pathway is used almost exclusively in enterocytes of the small intestines for the synthesis of triglycerides from dietary fatty acids. Triglycerides are synthesized by virtually all cells. The major tissues for triglyceride synthesis are the small intestine, the liver, and adipocytes. Except for the intestine and adipocytes, triglyceride synthesis begins with glycerol 3-phosphate. So next, we move to the synthesis of triglyceride. Glycerol is first phosphorylated by glycerol kinase and form glycerol 3-phosphate. Dihydroxyacone phosphate is reduced to become glycerol 3-phosphate using NADH as a cofactor. NADH is converted to NAD+. With the addition of 2 fatty acyl-CoA, glycerol 3-phosphate is converted to phosphatidic acid. This step produces 2-CoA as the byproduct. Next, phosphatidic acid is converted into diacylglycerol with phosphate as the byproduct. With the addition of the 3rd fatty acyl-CoA, diacylglycerol is now converted into the final product, which is triglyceride. The byproduct of this final step is CoA.